So I'm recording this for those that aren't able to join us in real time. There's a little bit more about parabolas, the connections between them, how do we graph them, how do we figure out equations, how do we work with them in a table, and so on and so forth. So in these first two pages, these are the two problems or two problem sets that we're going to work through. First one, we go from a table to an equation. The second part, we focus on factored form a bit more, solving for the a value, and then a familiar word problem to make sense of. Okay. Uh, Double check. No one has questions. Feel free to interrupt me at any point. Just unmute your mic and say something, and I will be able to answer you. Okay, and if you are typing everything to the whole class, then make sure you go to the Algebra 1 channel. Alright, so, and let's get started. So here's the first part. Over here, we have a table. Here are the values, and I'll stop moving my screen at this point. And from yesterday, I kind of jumped into the process of the zero product property and coming up with an equation for it. But now we can kind of slow down and go through that process, right? Our textbook describes it as reversing your understanding of the zero product property. That is, if we know the intercepts, can we come up with the equation? Versus before, we had the equation in standard form. It looked like x, oops. It looked like before we started with like x squared plus 2x plus 2, and then we went into factored form, right? Something, something, blah, 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 blah. And now we're going the other way. Now, since we know our intercepts, we can come up with the factored form and then come up with the equation. Okay, two sides of the same coin. So over here, if you're staring at the table in front of you, you should be able to identify some special points here. Anyone want to type into the chat in Discord or just speak up on what do you know is special about some of these points in this table in front of you? Any ideas? No? You're thinking? Okay, thank you, Jimmy. There are zeros, yes. So let me highlight them. That's always a good part to start with. We know there's something special about these 3 points. Okay, very good. And I'll ask a more leading question. Can you identify which one of these 3 points is the y-intercept based on what you know about a y-intercept? Is it this one, or this one? Which one's the y-intercept? Okay, and all this we're trying to do based on the definition without like a picture, right? So maybe I'll just draw a quick sketch of the picture. I think it looks like this, right? Okay, that's what our parabola looks like. If you could have skipped this, but since there's not much reply, I'll draw it. Okay, that thing over here is your y-intercept. And you think about the coordinates. They look a certain way. Which of these is the 0? Is it this one or this coordinate? Okay. You think, okay, I need -6 here for the y, so it should look like this. Okay, that's the process. For y-intercepts, x has to equal 0, y is your value. So for here, this thing is our y-intercept. And then on the flip side, these two things are your x-intercepts. And in my COVID review, I go through algebraically how you can determine that. Here it's like, okay, when y is 0, this is an x-intercept. When y is 0, that's your second x-intercept. And for here, when x is 0, this is your y-intercept. Okay, Gary, I'm glad you're having fun. X-int and x-int. Oh gosh, now I hear myself twice. Okay, questions so far? 0, -6. Oh, very good. Yes, very good, Diego. So from there, we need to find the rule. What clues in the table help you find the rule? How can you go about checking your equation using a graphing calculator? We're going to skip that last part. Since we identified the x-intercepts, now we can go through and reverse zero product property to figure out its equation. So y equals a times x plus 3 and x minus 2. That's what we know so far about our parabola. See how these things match up with the intercepts, okay? So there's some kind of opposite relationship with the signs. Remember, we want this whole quantity that I'm currently underlining to equal 0. Oh, okay. Give me a second. Okay, so Alexi on Zoom, can you see things now? Yes? So Gary can help you out. He's tech savvy, strong-spirited one. Okay, message him. Okay, great. Thanks, Gary. So, so far, what we've done is we've sketched a parabola, but really we're working with a table in this case. We went through and discussed, okay, these 3 points are special, that's the y-intercept, but really to come up with the equation, we are focusing on the x-intercepts. Okay. The Discord stream is blurry. Okay, let me increase the quality then. All right, Mr. Ben, is that better? Give it a second. How's that look? So I changed the quality on Discord. Is that any better? It's the same. How's that? Better? Because it looks okay for me. If you want to somehow refresh it or sometimes like stop watching and then join back in, maybe it'll update the settings. So try that out. Better now? Okay. So Mr. Ben, you may want to try that, okay? Exit out of the go live session and then watch it again. And for Gary, you may want to go refresh the page and then join back in. Okay, good. So it's clearer, yes? So sometimes it takes them a while to load. Just let me know via chat if something comes up. A more immediate feedback will come out from speaking up in the mic. Yes, I don't know what server boost is, right? You have to pay money. I don't want to pay money just yet until we're set on distance learning and I make someone else pay for it. I'm not going to pay for it. All right, so back to this problem. Again, we have this a value out here. That's the thing that narrows it down to specific parabolas. Okay, we need to solve for a. In this case, let's do some multiplying. Y equals a, and then we have this equation plus 1x minus 6. So this comes from drawing the box plus 3x minus 2 and then combining some like terms. Okay, so when we do that, we get this bunch. And now we got to think, okay, we have lots of choices. We know all these points are points on your parabola. okay, including the y-intercept, all these things, right? So you can choose any of those to figure out what the a value is, and it may end up being 1. That's okay. We'll just demonstrate this process. I want you to be sure that, because like last year when I taught this, I underemphasized the a value at first, and lots of students missed it. They lost points because, oh, they got the right intercepts, but their stretch factor or this a value was off. So then I might be overemphasizing it this year, but only like a third of you are hearing it out of my class of like 60. So we'll see. Okay. For here, let's use we'll pick a point. Any particular points speak to you? No? Well then, we can choose to use, let's say 0, -6 to solve for a. So that's your x, that's your y. -6 equals a times 0 squared plus 1 times 0 minus 6. Great. 6 equals a times -6, so a has to equal 1. Okay, we just confirmed. Nothing additional is happening. So for this one, the rule is, and we'll write it again, in factored form, it looks like this, using your x-intercepts. From expanding it or multiplying it through, your quadratic in standard form looks like this. What's up? Wow. Gary, why you do that? So I hear two of me. No, it paused for a while. Okay, yeah, 1 second, some technical difficulties. Sorry, let me scroll down to the next problem. Okay, and for those tuning in, you can work on that. Yes, that's better, Gary. Okay, can you combine into factored form? Yes, you can, but it, like, going beyond, where is it? So, I'll scroll up a little bit. Sorry for those looking at it. So for here, like, can you combine a into factor form? Yes, but it doesn't, like, I'm trying to think. There was an example I gave before, like in in your like part 1 test, you had something that could only be factored like once. That's one example of combining this a value into factored form. But for now, we'll just leave it out here. Like, for example, you could distribute this into the first factor. That's okay. Yeah. But if you're given like the x-intercepts, solving for that's a little bit harder. But yes, you can do so. That would still be algebraically correct. So good question, Mr. Ben. Okay, so for here, different table, same idea. We want to come up with the equation for this quadratic, this parabola. So just like what Jimmy said, we're looking at the zeros, something special there. And noticing here is your y-intercept by definition, because x is 0. Here's your x-intercept. Here's your x-intercept. And then going into factored form, we can do y equals a x plus 5, because we want, again, this whole thing to equal 0. So if our x value is -5, we have to add 5 to make 0. And for here, x minus 5, oops, nope, looked the wrong one, x minus 1. Okay, that's utilizing this point over here, because 1 minus 1 makes 0. And now we can check. Maybe this time we'll use something different. We can use a different point, or maybe we'll just leave it here, right? Now solve for a using, you don't have to always use the y-intercept. Maybe we'll use this point, 2 comma 7, some point on parabola. So we could, this time, let's leave it in a factored form. Okay, we know the x value here is 2 plus 5, 2 minus 1, and then back here we know its y value. It's 7. So 7 equals a times 7 times 1. Oh, looks like again we see that. So 7 equals 7a. A has to equal 1. Nothing special there. And at this point we can factor it, we can expand it, x squared plus 4x minus 5. And then in factored form, y equals x plus 5, x minus 1. Cool. Did it work? Should try rejoining. Okay, if you can't see your screen, I'm unsure if it pops out. If you're on the laptop, I'm unsure. Ask the class. Let's see. Well, because you're on Zoom and on Discord, so that's why you see two of me. Okay, class, what's the move? If someone could help out O over here, he's having difficulty seeing my screen. So while we're on this problem, since this one has so many points, I wonder, can you find where the vertex is, okay, in this parabola? Can you see it based on these patterns? So the vertex is the minimum or the maximum, and you know where the x-intercept is. So let's see if we can use that idea to help you find the vertex in a table. Think about it. So algebraically, it may be hard. So think about, again, your graph, okay? If -5 is way over here, and let's say +1's over here, those are your x-intercepts. You know your y-intercept is about here. So then your parabola looks something like this. And so right in the middle between your x-intercepts, that's your vertex. My graph is a little bit off. So on a table, you would ask yourself, okay, where is halfway in between these x-coordinates, these x-intercepts? So you can skip, go over 1, go over 1, skip over 2, skip over 2, 3, and 3. So this thing over here should be the vertex. On a table, when you have all these values of integers, it's kind of nice to see, like here visually, right? And then that's the middle, that's your vertex, that's your line of symmetry. And then you kind of notice in amongst these x values, they repeat, okay? 8, -8, -8, -5, -5, 0, 0, 7, and 7, so on and so forth. You see the symmetry kind of nicely on the table. And if you're able to identify that while you're working with a table, then you could just go straight to vertex form. You don't have to like go through other things. All right. Frankie, you can always join the Zoom thing too. My screen, your classmates are streaming me streaming Discord on Zoom, so that's a backup. All right, questions on this problem? All right, so going down, the third one focuses on some connections between this form, namely factored form and some word problems, okay? So a journalist from a school newspaper, we're going back to the water balloon contest, okay? She wants a rule for each toss so she can program her computer to create a graph for her article. You already have the rule based on the first problem we did in this chapter, okay? You remember these people? Jen, Eris, Maggie, Nanimus, right? Impetuous and all that. So in A, the journalist knows that factored form of equation looks like this. What do B and C represent in this factored form? Someone type it out onto either chat. What do B and C represent in this equation in factored form? No? Type, please. Thank you, quack quack. When the balloon is on the ground, even more so. Like, for the features of a parabola, what does it mean when the balloon's on the ground? So here, I'll just write it. B and C are the x-intercepts. Cool. And then we examine this graph on the right. This is the one that was given to you in the water balloon task. Okay. Journalist found the rule. Looks like this. So just like before, now we know how. Use any point on the parabola to solve for A. So in this case, right here, right here, make this go away. Okay, right here, that's 4 comma 32. We know that point. You know the x-intercept, so that's not going to help you too much to solve for A. So we're going to use that to help us out. Using the maximum 4 comma 32, that's an x, that's a y. Y equals A times x minus 0, x minus 8. I'm just copying down the equation from before. Plug in x and y, okay, from above. 32 equals A x, oops, we know what x is. We know x is 4, and this one is 4 minus 8. 32 equals A times 4 minus 4. 32 equals A times negative 16. Divide both sides by negative 16. A equals negative 2. So factored form is y equals negative 2 times x, and then x minus 8. I guess we could make it a bit more obvious, the other intercept, and do minus 0 here. Same thing. Standard form is y equals negative 2 times x squared minus 8x, which equals negative 2x squared plus 16x. Okay, that's standard form. Questions, comments? All right, so that's parts A through C, and just goes over what we've been working on, factored form when given, particularly the x-intercepts, its reverse zero product property to figure out the equation of a parabola. And then we're down to part D. Now we're going back to a word problem. Let's see if we are given this information, can we construct an equation of the path of the balloon? So Al released his balloon. What color haven't I used yet? Let's use orange. Okay, Al released his balloon from the 10-yard line and it landed on the 16-yard line. If the ball reached a height of 27 yards, what equation represents the path of his toss? So for part D, if I were sketching it, okay, you know it looks something like this. Okay, so there's your parabola. There's your maximum. That's 27 for the y. And then because he tossed it from the 10-yard line, notice it's different than before. He didn't start at 0 where the thing is. So that's 10. And then it landed at the 16-yard line. So that's what Jimmy was saying. These x-intercepts is where it touches the ground because your height is 0 at that point. Y goes up, right? Y is 0, it's the ground. So from here, we can solve. Okay, we have 2 points. We know our x-intercepts. If we want to be even more specific with this, we would write it out like this. And factored form, here we go, minus 10, x minus 16. And the harder part now is solving for A. Okay, you see us use this idea many times. We don't know the x-coordinate or the axis of symmetry for our parabola as of right now. So we got to think, okay? From 10 going on 16, that's a total of 6 yards. Halfway in between makes 3 yards and 3 yards. The vertex is always in the middle of your x-intercepts. That's this idea. You may have seen me write out this equation from before. It's that one again. But this one's not going to be too helpful because we don't know our v value. Okay. So that means this point has to be 13. I can write that a little bit better. Okay, that should be 13. And then you know it went at 13 yards, it went 27 yards high. So using another point we know for sure is on our parabola, the vertex, the maximum or vertex of 13, 27, we can now solve for A. 27 equals A times 13 minus 10, 13 minus 16. 27 equals A times 3 minus 3. 27 equals A times negative 9, divide by negative 9, that equals negative 3 equals A. Y equals negative 3 x minus 10 times x minus 16 That's your factored form equation, and you could multiply it out to figure out standard form too. Y equals negative 3 x squared plus 160 plus 20, oh, minus 26 x. So y equals negative 3x squared plus 78x minus 0.82. That's some really big equation. Either of these will be acceptable unless I specify factored form or standard form. Okay. Factor form, you see it's easier. Oh, 38. Did I mess up? You're right. Yeah, 38. My bad. Thanks, Ben. Wait. What? 38? Ah, here's my mistake. I see. Thanks. Wait. Did I mess up? 38. Isn't it 16 plus 10? Ah, okay. So, yeah, be careful. If you use your x-intercepts, it should be like adding these two things, right? So we can draw the box. I'm just doing FOIL. It should be minus 26. But whatever I had before, it looks like that was right. And then 26 times 3, 8, 5, 68. Seems about right. Okay, you know for sure factored form is right. That's part D. And now let's talk about part E. Brown. Right? Zoom out a little bit. So remember IMP's water balloon toss? Since the water balloon was thrown on the computer, they were given only a table, okay, shown below. Find the rule that represents IMP's balloon as it traveled through the air. This one, oh gosh, yeah, this one's going to take a little while. And you notice in this problem, okay, we don't have our x-intercepts obviously staring us in the face. We know that this thing over here is your y, no, is it? Yeah, this thing is your x-intercept. But at the moment, we don't know its other x-intercept. So any ideas on how we can go about finding another point so that this stuff works? Think to yourself for a little bit. We only know one x-intercept so far. We know these points from our table. And so one way to go about it that kind of emphasizes the vertex, the middle idea, okay, is that there's your first intercept. Notice right now our ball, if I were to sketch it in brown, okay, you start at 2 yards, it goes up, and then eventually it falls back down. Okay, so for us, notice this pattern, right? It goes up, goes up, goes up, goes up, goes up, and then at this point it starts falling down. So you know from this sketch that this thing right here is the point 7, 25. That's the vertex maximum. Okay, and this point over here is 2, 0. Now we gotta wonder, where's this other point? Where's our second x-intercept? Well then, we can work backwards, right? So there's 1, 2, 3, 4, 5 little arrows. So then we can draw 5 more arrows. 1, 2, 3, 4, 5. So this thing should be 12, 0, making use of that symmetry that the vertex is in the middle. So this is an 11. Okay, and we can even figure out what these coordinates would be, right? After 21 comes 16, then it falls back down to 9, then it goes back down to 0. Okay, so I'm extending my table. And now we have our two x-intercepts, making use of symmetry. So we can set it up, y equals a, and in factored form, there's our first x-intercept, here's our second x-intercept. Now we can choose to use, like, you don't always have to use the vertex. Let's use maybe the point 3, 9, which is some point we know is on the parabola to solve for a. So there's your x, there's your y. 9 equals a. 3 minus 2, 3 minus 12. 9 equals a times 1 minus 9. So a has to equal -1. Okay, I skipped some algebra steps there. So your final equation is -1 x minus 2 x minus 12. Let's turn it into standard form. -1 times x squared minus 14x plus 24. And then because of this -1, we change the signs in each of these terms. So there's our answer for part E. Yes, very good. Good job, Mr. Ben. You got it right. Thank you for participating. So here we demonstrated this process. If we're given a parabola, if we're given some information, either in table form, in graph form, it's helpful to figure out the x-intercepts, because then we can go to factored form and we can figure out the equation of our parabola. This is more practice for that. I highly recommend you do the COVID reviews because it emphasizes those skills of finding specifically x and y intercepts. A big idea we needed to solve these problems. You can do so with lines. And later on, even in like your later math classes like pre-calc and calculus, you still use those ideas of x and y intercepts. That much remains the same. Okay. Before you go, I want you to type in the chat so I have a record. Tomorrow, I may try out Google Meets, try out some other tools, see which one works best. I'm kind of liking Zoom more, but Discord works pretty nicely too for my math lessons. In chat, I want you to type out, okay, what do you want Mr. Chan to talk about? Okay, so, oh, thanks. Okay. So 1, math at Lowell. Okay, 2, algebra 1 stuff about parabolas. Okay, or 3, other classes and arena at Lowell. And then 4, other. Okay, so 4 is the option where you just say stuff you want me to talk about. Yeah, course selection. 3, okay. I can talk about my experience at Lowell. 3, okay. So just comment, give me some feedback. So then the next lesson is less about, or a little bit of math if that's requested, but then I can guide you through that process. Remember, your teacher, you have the fortunate, like what? You were paired up with a teacher that went to Lowell, right? Okay. Yeah, so tomorrow's lecture will mainly be about other classes at Lowell. I can talk about the classes I took at Lowell, looking ahead, because like when I was in like college, at like times when I didn't know what to do with myself, I would look at like what jobs I could apply for or what other future classes I can take, so I can advise on that. Come ready with some questions if you want some of this advising. Like, I hope you participate more and you ask me questions like in chat or in Zoom and Google Meets, whatever we end up using. Okay. Be sure to check Piazza for our next setup, whether that's Zoom, here in Discord, or in Google Meets. That's the third thing. I tried it a little bit today. It may work out pretty nicely. And yeah, uh, tell your friends if you see them, if you message them to like check Piazza daily, also check your email daily. And that's it for today, class. See you later. Session 2 is at 4.